Welcome to Season 1 of Concrete Conversations. Today we are talking about the foundations of our world. I recently attended the 64th Annual St. Mary's Concrete School, specifically the Northeast class, and saw how the industry is bridging the gap between decades of tradition and the future of material science. This guest is a veteran powerhouse in our industry. Please welcome Rick Blackburn.
Good morning, everyone.
Rick, I want to start at the waterfront. Anyone who's been to one of the CIB plant tours at the St. Mary's Bronx Terminal knows that it's a marvel of logistics, especially seeing that massive pneumatic system at Oak Point. It's the first project ever to receive a WEDG certification. How is that facility specifically helping New York City producers bridge the gap between traditional methods and this new era of Type 1L cement?
Well, it originally started out not for 1L. It started out as a Type 1-2 terminal. With that being said, we have transitioned after a couple years into 1L cement. The material itself, the logistics is that it is such a centralized location for the Bronx and coming out onto the island. It just helps everyone get their material in a more expedient manner. And with, like you said, the wedge certification showing the ability to have less dust produced per as we go on. There's just less pollutants in the air and it helps make things get out faster. It loads fast and it also gives you the material gone. So you have a quicker turnaround, faster material gets to you. You don't have to worry about it.
Now, I want to ask a hard question. I've been seeing a lot of scaling issues on sidewalks in this New York region, specifically Region 10 of Long Island as well. I was wondering if you could reflect on that, being the concrete advocate you are.
Of course. With the advent of 1L cements, there has been a change in how the concrete is to be placed. And what happens is that a lot of people, or a lot of people who place the concrete, I should say, have had issue with how it's finished. A lot of material research being done on this right now is showing that a lot of people are getting on the sidewalks, particularly way too fast. The material is still losing its bleed water, and contractors and finishers seem to be getting on it and trapping that initial bleed water into the top surface. And when you have a winter like we had this year, what happens is that bleed water is trapped there, it expands, it pushes against the aggregate below it and the mortar layer above it, thereby finding the zone of weakness being the mortar, and it spalls. And that's where you get your salt scaling or ice scaling, as most people call it. The material itself, the rest of the concrete is doing fine, but these bleed channels underneath the initial finish layer seem to be the root cause of that issue. And there's been multiple articles. There was one on concrete placement in October, and recently in Concrete International, this latest issue has one specifically addressing the and scaling, where the final conclusion from the material engineer or slash petrographer who ran this article, he says that L and 1-2 cements perform the same. So the issue seems to be elsewhere. So that's where we're looking.
What a thorough answer from a concrete guru such as yourself, and I appreciate that, especially the educational mission that I've been happily a part of, attending the concrete school, and as well as just corresponding with you over the years in the industry. So I wanted to just share that right now. I know concrete education and concrete advocacy is a strong topic in your life. So if you wanted to continue to reflect on such, I'd love to hear it.
As you said, you attended the 64th annual class. As hopefully most of you can tell, I am not 64 years old. So the class had been developed out of our Detroit facility over the past decades and honed, and we've cut it down and we've added, we've rolled with the technologies, and we've produced a class that gives you an overall feeling of the actual industry, not just cement. We do talk about that. We do go into modern concrete placement, and as well as a lot of math with the design. The people who leave, some have some knowledge in let's just say, design, but they've never really gone out in the field and seen it placed. Or there's people who are never into the logistics or looking at the actual how the cement comes into their plants. As they leave, they have a more cosmopolitan look at the overall industry, but they also know that there's more out there to learn. I've been in this business since 95 and I'm still learning every year new stuff, new materials, new technologies, new applications, new finishing techniques. It is a vast area of a repository of learning. And it's my goal is to make sure everyone out there has the same level so that we all can work on a level table and be able to come together and solve for better technologies, better long lasting concrete, and better overall materials. I want this stuff to last 100 plus years. And that's what I'm trying to help people do.
For sure. The big part of this episode is I would love to showcase your high level expertise in mixed design, workability, and sustainability. Being that just overall, you're a brilliant man. So, point one is we want to talk about workability versus slump and the insight that you have towards that.
Okay. One of the things that I try to help with finishers is that what I used to call when I was working for a ready mix supplier up in the Northeast, we used to call it a Friday Five, and how customers would come in, take our material, and add enough water that it, say it's a floor, say it's a sidewalk, that it would self level. That, in an instance, one, it dilutes the overall concrete, making it a weaker process. It helps with it actually increases the air entrainment, making the top surface less durable. It also makes the overall strength less. It dilutes everything about the concrete. And it also lengthens your finishing time. You know, we had customers that their dads placed concrete, their grandfathers placed concrete. Well, their grandfathers placed concrete at like a 4-inch slump. Their dads might have, you know, with some modern technologies like water reducers and whatnot, might have taken their slump up to a 5, maybe a 6. I know I see people pouring foundations where the paste and sand go down one side of the hill of the concrete and it goes and all the aggregate falls to the other, and they just make it up with vibration. This is one of the issues in the business that I try to help with is to create a better finishing material, but you don't always have to have the slump. You can lower different aspects of the design to help or maximize placement without sacrificing quality. And that's what one of the attributes of the classes we talk about also is to make something more user friendly so that in the end you look like the genius, not me.
So, the next topic that we want to talk about is the sustainability paradox. It's schedule versus carbon. So, the insight here is reducing carbon, but extending set times and strength gain. And if you could reflect your insight on that.
Sure. I am a very large proponent of SCM replacement in concrete. SCM is supplemental cementitious materials. It could be anything from fly ash and slag or to more exotic materials like calcined clays, metakaolin, or as other people use, silica fume. So these supplemental cementitious materials can help create a more sustainable concrete. But with the addition of those, sometimes you have to make an adjustment with admixtures to continue it to be finishing as well as getting your initial strengths so that your contractor or supplier has a better turnaround. They can strip the forms on the next day and they can go to the next section. They don't have to crack the forms and see if it's still green underneath. They want to have that turnaround and that early strength so that you can continue on a project at an accelerated construction pace because that's what everyone wants. They give you 6 months to run a project, but they really want it done in 5. You know, I was doing a string of grocery stores up in the New England area, and it was a large chain up there. We went for a meeting because they said you could only place at a maximum 4.5-inch slump. The contractor who was placing the floors wanted a 5.5. The engineers said no. We kept going back and forth. We finally had a meeting at their big corporate headquarters, and The person who ran the engineer division said, "You can guarantee this." I said, "Yes." He's like, "All I care about is getting those registers ringing. You deliver, I don't care." And it comes down to that. You got to be able to produce something that makes everyone happy. You get those nice shiny floors. You get those sidewalks that hold their ridges for decades. That the trees end up heaving up later. That's a different subject. But you have that stuff that creates the right now in the industry, there's a phrase, it's concreted, it's something. We're still trying to produce that result. We want it to be the basis of all. We want it to be concrete. So with that, that's what we're trying to do.
In your experience of technical excellence, what would you say is the golden rule?
Water is death, but water is needed. The American Cement Association, formerly the PCA, says that for concrete to be properly hydrated, it needs a water cement ratio of a maximum or a minimum of 0.27. We in the industry, the American Concrete Institute, the National Concrete Ready Mix Association, the American Society of Testing Measures, we've expanded that because we need water convenience to help finish. A 0.27 will hydrate, but you're never going to close it up. So you need that water to help activate the paste in finishing the concrete, saying a point for a roadway or a bridge. There's a reason for that. You don't have as much water, but you have heavier machines to help finish it. For sidewalks, they say a 0.44 to 0.45. Now, with that, you can use water reducers to help you get that flow that you want and still not sacrifice the quality of the overall concrete. Where water is helpful, it helps hydrates, but it also, if you add too much water, if you go over a point 0.5 or a point 0.6, I've seen Petros come back at a point 0.7, which means that as you learned about the box, a cubic yard of concrete is 3 feet by 3 feet by 3 feet. If you add so much water to a design mix, something has to come out of that box. So in coming out of that box, it's usually your cement and your finer sand particles because people keep the aggregates in there. And so you're sacrificing, once again, diminishing the overall product and making it harder for it to have a long and useful shelf life.
Next question. What is the highest compressive strength mix you've ever designed?
The highest I've ever designed is about 15,000 psi. It was breaking over that, but I mean, the design was 15. It was for a casino outside Atlantic City. And we did work. I was working at a chemical admixture company that was attached to a cement company at the time. I was doing research on the modern polycarboxylates, which is now about 3 generations of polycarboxylate ago. But you just keep up on this. And we were doing the walls, elevator shafts, and the foundations. With the foundations ended up having about 75% slag in them, and they were achieving 12,000 psi in 7 days with an over design after that. I mean, they made the 15 easy.
Beautiful. We have a special guest with a question. I'm going to pass the microphone to the general manager of Ready Mix at Nicolia Industries, my older brother, Alex Nicolia. Here you go, Alex.
All right, thank you. So, Richie, how you doing?
I'm doing good, so how
Good.
you doing?
Fantastic.
Excellent.
My question was regarding a common that happens when reading a spec. I found that 10 or 15 years ago, I kept getting specs where everything was revolved around water cement ratios. And I think that still happens, but what I'm seeing is that the spec on slump and water cement ratio has considered the addition of mix water reducers 10, 15 years ago, like I was referencing. And now I'm starting to see that again, where they're talking about, sticking to certain water cement ratios. I see recently also we've been able to reduce our cements from 720 used to be our 5,000 to 658 kind of, and now I think we have some that are even less than that and are called 5,000s. So I guess my question is, have the engineers that make these specs gotten with the times? Even now, I mean, we have EPDs and all that new stuff. When I see those, obviously, I know that to a degree they have, but then there's still like another half of the spec that's antiquated that I see that they just tacked in there. So, are we going to see like any kind of modernization in that aspect? Is the cement supplier helping us producers to manage, or, these kind of questions are, we don't realize exactly when these changes occurred down the line where you might, and also we want to help our customers the best that we can and give them the right information.
Always. Okay, to address specifications. I used to read over those about the same time you did, about 10, 15 years ago. I mean, I still read them. People send them to me. AIA, American Institute of Architects, master spec. Most modern engineering houses will buy into the AIA master spec. So where you're seeing the progression is because people are not just going to the shelf, blowing off an old spec from 10 years ago, going, hey, it worked at the ABC project, we're fine. We'll just use this again. They not changing in chemicals of either a ASTM 260 air entrainer or a C494, a water reducer, retarder, specialty product, accelerator. All those have changed over the years. I came when I used to jump up on trucks when I first started. We used to have the pony tanks on the side of the trucks that held Rio Build one. Well, yeah, an old master builders project. We were in Cleveland, but it held gallons of it. And we were dosing it at 24 ounces per hundredweight. And they only had 40 minutes before you lost all your slump. So then they moved on to polycarboxylates. They have a longer shelf life and travel, so you lose the pony. It took a long time for those specs to be updated because people were just using antiquated knowledge. I think now with the advent of modern communication, which is another big thing that I push for, is, when you get a spec or you get a spec or you see something on there that's old, challenge it. Call the engineer up right away. Talk to him. Say, hey, what's this Vinsol resin air entrainer? No one's made that in 20 years. And I was still seeing that 8 years ago when I was looking at specifications. Some people still call for old generation polynaphthalene sulfonates, PNS, or melamine-based superplasticizers. Those are the pony tanks. Those are the ones when you put it in the concrete, it made it smell like you were back in your biology class dissecting frogs, because polynaphthalene sulfonate is formaldehyde. There you go. But people are starting to progress a little faster. The EPD movement, yes, that's going to add a lot to, yeah. But there is a general goal in modern concrete submissions, and it's going from prescriptive mixes to performance-based mixes, where you can go to an engineering house that's building, let's say it's a giant box store. You can say, look, here's my mix, here's my history, here's my shrinkage, here's my curling. You can show your durability testing. But you can brand your mix if you want, or you give it to them flat out, but you can say this is performance based. And yeah, my water cement ratio is different than you have submitted, but no one runs a 0.35 water cement ratio on a 4,000 PSI. That's a 6,000 PSI. And what I used to tell them, the engineers, if you want that 3.5, I can give it to you, but it's going to cost more. You're going to have a faster turnaround because, yeah, you're going to be putting that 752 into the mix. A lot of people are looking at that, and they also see that for the longevity, it's better to go with less cement. It's better to go with better, what we talked about, packing density of the aggregates, making sure everything fits together. That way it helps with the finish. It helps with the timing. It helps with early strength gain. You're not putting in as much water. You're lowering your paste factors. And yes, I know most of our, you're all your eyes are glazing over right now, and I apologize. But the engineering community is coming around. But if you see something out there, it's just like a safety thing. If you see something, do something. If you see these older specs, challenge them. Call me up. I've been challenging these older admixtures for 20 years. I had someone call me last week about an outdated one, and I floated them a letter, and we'll see how that turns out. But for the most part, everything in this industry is changing. The specs need, a lot of engineers like to trust but verify, and sometimes that takes a while for it to catch up. I'm not blaming them. I'm just saying that this market is changing fast. As we talked about earlier, the introduction of 1L cements has been one of the bigger things. 15 years ago, it was the introduction of polycarboxylates into your mixes and how they, some people had trouble with them. Some people had trouble finishing them, but they've gotten used to them. What most people don't understand is that standard 1-2 cement has been changing through the decades. It was originally in the 20s, it was first put out as a 1 or a 2 cement. And that ran for a long time. In the early 2000s, people saw that they could, see that there's an overlap between type 1 and type 2 cement. So they're like, okay, do I fit in between those two? I can make type 1, 2 and sell to a broader market. Ergo 1-2 was born. Shortly after that, ASTM changed that they allowed up to 5% limestone addition into their cement. So now you have 5% limestone addition. That changed everything. People had to adjust. And that's just with C150 cement. Now comes the more environmental look, and we are running C595 cements. They have up to 15% allowed. I don't know anyone who really goes above 12. There's certain people who have tried. We sit around 10, so ours is roughly around 10%. I'm just speaking, as my thing. I know that there's other suppliers that run about 8. And so that is a change. The most constant thing in this business is change, but getting others to move on with that change is the real challenge. Is that about right?
Yeah, thank you.
All right, folks, we're going to nerd out. We're going to concrete nerd out.
What, we weren't just doing that?
We're going to nerd out even more. We're going to crank it to who invented the modern Portland cement and when did that take place? Because I know you know the answer to that.
It's part of my class. It's all a good thing. Good seeing you, man. So our modern cement was first produced about 201 years ago. We just celebrated its bicentennial last year during the eclipse. I celebrated with my dog on my back porch, and his name was Joseph Aspdin, ASP, Aspdin. He created it in his little laboratory in Portland, England. He was trying to find a better way to create mortar, and he just started burning things. And luckily, he didn't burn down his lab. But a lot of people, when they try and figure these things out, the first thing they do is they put fire to it. That's how we got sugar. They started burning plants. But Joseph came around and found that if he burned certain chemicals, like I talk in the class, the main components of modern day cement is a name called LISA, which is limestone, iron, silica, and aluminum. And it's the main component of at least 80% of the material that goes into modern day cement. So he was the one who originally came up with part of this. He used what was a vertical kiln, basically like the old town. They just were able to make charcoal with it, but he also used it to burn at high temperatures, some limestone, and then fine ground it and found it had what we call a pozzolanic activity, meaning that with water and also hydraulic, meaning that it reacted with water and created strength through that. So how's that?
That is fantastic. Thank you for sharing that with us. What are you currently nerding out on within the concrete industry realm?
Well, it sort of goes to back what we were talking about earlier. I am nerding out about the possibility of creating concrete through chemistry, making it survive longer, giving it better durability, giving it better strength through different admixtures and or supplemental cementitious materials, making it so that it lasts. With this change that's coming about, a lot of people have focused on strength. A lot of people have focused, a lot of DOTs look at durability. They want to know what the resistivity or the conductivity of the concrete is to see how long it takes ions to flow through the concrete that could cause it damage, like ASR, like corrosion and stuff like that. So in making concrete that is able to withstand and be longevity, we've also found that the material lasts longer. You're making it better. You can go on to certain programs online and type in certain criteria. You put in how many years you want the concrete to survive, 75, 100. Some people want to try 100 plus. With that, you have used different, like I said, supplementals, and the concrete itself will still give you your strength, but sometimes you do have to wait for that 56-day break. And some people don't like that because, once again, that leads to the turnaround. But if you're doing a large scale paving project where the road isn't going to be opened in 28 days, if it's going to be open next spring, you can wait and you can create a better quality product. And with that, a better surface that makes it safer for people to drive over for decades.
Beautifully said. I'm going to close this out with a bonus because I work in threes. So if it's a fourth, we call it bonus. You did tell me that you wanted to speak about the story of the Bronx. I will let you further reflect.
Well, of the Bronx Terminal.
Of the Bronx Terminal.
Yes. When the Bronx Terminal opened, and this is 8 years ago, it was the newest docks that was put on the Long Island Sound in 50 years. We took a piece of property and we leveled it off. We put this terminal up, which is a warehouse style terminal. So it's flat storage. It's not like giant silos. So we do have a person in there pushing cement around all day long. And if you think cement like holds together when you're scooping it up, no, it pushes like it's ball bearings. So there's a person in a front end loader all day loading into the pneumatic system that we discussed at the very beginning. But when that was finally put together, approved, we got all our certifications. We had a nice big opening party. We invited our customers. We had food and everything. We had speakers, dignitaries, mayors, state reps all showed up for the first active marine terminal in 50 years. Our then CEO, his name was Jean Moreau, a very nice man who was integral into getting the product into the Bronx as well as our Providence terminal in Rhode Island. He came down, he gave this big, beautiful speech talking about, the blending of the Bronx as well as the McGinnis cement product. And at the very end of his speech, he was wearing one hard hat that said, I think it had the Bronx on it. And he took it off and he put on his favorite team's hard hat, which ended up being the Boston Red Sox, right in front of the mayor of the Bronx. It was, I was in the back and I'm like, I'm getting out of here. There's going to be blood. But yeah, it's a good story to remember. But yeah, the terminal itself, the amount of material it's put through into your market, into going up into the Hudson River Valley, and the overall logistics and its location it's been a good project to be a part of. And knowing the environmental aspects of our current cement, I like looking into the future with it.
For sure. Rick, thank you. Thank you so much.
Thank you all
for driving down to Long Island for this interview. I want to thank St. Mary's. I want to thank our special guest, Alex Nicolia. I want to thank John Filiberto. I want to thank the entire board and all the members of the Concrete Industry Board of New York City. Maybe one more mention.
I just want to say, I'm just happy to be here. It's an honor.
So happy to have you.
Yeah, it's just an honor that I was able to be asked to be here. I'm happy that my upper management said, yes, do this. And I would like to say that I hope that I made my wife and daughter happy by not saying too many things.
Well, we appreciate you folks. Follow us on the next episode, and we'll see you soon. Thank you.
Be safe all.